Okay, so this is about sacrificial protection and how it works. Now, essentially, it's about a competition between two different metals of different reactivities. So the iron is the one that we know rusts and causes problems. So I'm going to look at two pairings of it. So iron with more reactive metals and iron with a less reactive metal, so that we can understand what's going on. Now, we know that when iron rusts, it's actually being oxidised. It combines with oxygen. And we also know that the process of oxidation involves having to lose electrons. Now, I'm going to set up an experiment where I have a piece of iron connected to a piece of another metal, and I'm going to use an ammeter in the middle to show me the direction of flow of electrons. So if the electrons are flowing in the direction of the arrows here, I'm going to see it as a minus sign on my ammeter. If the electrons are flowing in the opposite direction, I'm going to see it as a positive sign on my ammeter. Now, what I'm expecting is that if this metal here is more reactive than the iron, then this one is going to react with the solution first. Now, the process of a metal reacting is going to mean that the ions that are in the lattice are going to come out of the lattice and go into the solution, and they'll leave their electrons behind in the sea. Now, slowly over time, that will mean that the electrons will build up in the sea here and will eventually be repelled. So they will start to flow out of that piece of metal, and you can see the direction of the arrows here. They'll flow from that more reactive piece of metal onto the iron. Now, if the iron is trying to rust and become oxidised, the iron is trying to lose electrons, which means it's trying to lose its own electrons. Now, if it's got electrons from another metal flooding onto it, that makes its job of trying to oxidise and trying to rust even more difficult. So while we have the iron connected to a more reactive metal that's going to flood it with electrons all the time, the iron will stay in a reduced form, iron metal, rather than an oxidised form, rust. So this is the experiment now, and I've got a piece of iron here connected up to my ammeter, and on the other end of the wire I've got a piece of magnesium. So I'm going to try putting them together into this salt water solution so that I can see particularly the sign and the sign on my ammeter. Now, if the electrons are flowing from the magnesium onto the iron and helping keep it in its reduced form, I should see a negative sign on that. And the larger the negative sign, the better it is at doing that job. So let's put them in here. Now, I've used salt water because I know that salt water speeds up the process of rusting, so I'm hoping it's going to give me quite a good result. It's taking a little bit of time to settle. I think we get the idea. It's a large negative sign. It's around the 70s. Okay, so minus 70. So that definitely confirms that electrons, quite a lot of electrons, are flowing from the magnesium onto the iron. Now I'm going to compare it with something else. I'm going to connect a piece of zinc to this system. Now I know zinc is a reactive metal as well, but it's not quite as reactive as magnesium. So I'm still expecting that the electrons will flow from the zinc onto the iron. So I'm expecting I'll still see a minus sign, but perhaps not quite such a large minus sign as I have with the magnesium. Let's give that one a try. Well, it's definitely a minus sign, but again, not very large as predicted. So if I were to use something for sacrificial protection and I wanted to choose between magnesium and zinc, I can see the magnesium is much, much more effective at protecting the iron than the zinc is. Okay, now by contrast, I'm going to try something that's much less reactive than the iron. I'm going to use a piece of copper. Now, this time, in the competition between the iron and the copper, the iron should win that, which means that the iron should be the one that's being oxidised and should have its ions leaving the lattice, going into the solution, and the electrons flooding round from the iron onto the copper, which means I'll be reversing the flow of electrons from the previous system. So I'm hoping that I'll see this now as a positive sign on my ammeter to show that the electrons are flowing in the opposite direction. So let's give this one a try. There we are, sure enough. This one is a positive sign. So that's showing me that actually the copper is not protecting the iron at all. In fact, if anything, it's encouraging the iron to rust.